Hi everyone, welcome back to another Machine Learning Monday. Today I want to explore something new in the Azure Machine Learning Software Development Kit, which is model explainers. So I don't mind saying that I've been struggling with an element of this all morning. I get this very annoying type error, so unfortunately I haven't been able to visualize this to the extent that I'd like to, but I still think it's worth going through. So as we know, there can be massive issues in machine learning when it comes to trusting models. It's all very well and good for us to roll out all these amazing machine learning and artificial intelligence models, but if they remain black boxes, if clients and customers and citizens who are using them or in contact with them have no idea how they work, well, that's kind of a place where distrust can start to creep in. So one of the great things about the Azure Machine Learning Software Development Kit is that it has this inbuilt module called the Explainer and the Interpret modules, which allow you to literally break down what happens inside a machine learning model. So here I've created a very small machine learning experiment. It's literally looking at the Titanic dataset, which is used for hundreds of thousands of machine learning projects every year, and it is going to log the importance of each of the features within that dataset when it comes to determining whether someone survived or didn't survive the sinking of the Titanic. So I'll just walk you through my script and my script run configuration notebook. So here is my script in the machine learning environment that I've been working in. It's a really simple script. All it does is gets the data set from a local CSV. It defines the data set. It does a little bit of basic data cleaning, replacing some values with some dummy variables, and converting some data types, splitting it into your typical train test split. I have actually stratified this one, so it's slightly different to normal because we are going to look at some global and some local explanations. And I have just put it through a very simple random forest classifier. I haven't even specified the number of trees, so it's going to remain the defaults. And I'm just fitting it and getting the results in a confusion matrix. And I don't believe I've actually stored this in my machine learning workspace, so it's not going to come up when I run this model. Then here comes the clever bit. So there are lots of different explainer objects within the Azure Machine Learning SDK, and the one that you choose really depends on what kind of model you are utilizing. So in this case, I'm using a random forest model with tabular data. So it's all in a big spreadsheet type structure, and I'm using this tabular explainer. In the tabular explainer object, you provide 4 parameters. The first is your trained model, which in this case is my random forest classifier model, which classifies individuals into survived or not survived. My train data set, my features, which is a list here of the passenger class, their age, whether they had siblings or a spouse on board, whether they had any children, or whether they, if it was a child, whether they had parents on board, the fare they paid, their sex, which is a binary encoded feature, and where they embarked. So there are 3 different locations that people embarked onto the Titanic, and they are encoded as 0, 1, and 2. So those are my features, and my classes are 0 and 1, which stands for survived or didn't survive. 0 is didn't survive. And then what this does, this global explanation, is from all of the data, it figures out what was the contribution of each of those features to whether someone survived or didn't survive, which is really interesting, right? Looking at the data set as a whole, what's the relationship between all of these different metrics about an individual and what their outcome was? So that's our global importance. Then our local feature, I think, is arguably more important. So this actually interprets the feature importance on an individual record level. So what this does is I have identified the first 5 rows of my test data set, and I'm going to get the model to explain the importance of each one of those outcomes in terms of the features. So how did the features interpret, how did they lead to the interpretation that this person would or would not survive? And then I'm just going to print them all out. It's in a bunch of dictionaries, so you have to do it in some for loops to get the correct bits of information out. This is the bit that's providing me with all of the issues. The upload model explanation method of the explain client keeps giving me this funky error about comparing string and integer types. So if anyone knows anything about that, please let me know. Unfortunately, it means I can't actually get the visualizations, but I can still see the feature importances on the global and the local level, which is really interesting. So when I run this model, all I do is I just tab through all of the standard bits from creating an environment to provisioning a compute cluster to creating the script configuration environment for how the script is going to run. And then I just run my experiment. Typically, it takes about 60 seconds to run. And when it has finished running, it will store the output in the jobs tab, which is where all of the other experiments and my hyperdrive runs, which I've also made a video about, are also stored. Hyperdrive being how you tune your hyperparameters. So I think our code name for this experiment was Tough Break. Let's hope that this isn't a tough break. I have been banging my head on the desk a bit this morning over this model, so hopefully that's a somewhat ironic name, but we'll just give it another few moments here, and hopefully it should finish with a big green tick and we can go over and start to see the importance. So just while it's figuring out whether it's going to finish or not, oh, there we go, we're getting some response. That's always a good sign. Hey, there we go. All right, we've got the green tick. Fabulous. So that means we can head over to jobs. We can see the latest job, which is Tough Break, which is successfully completed. Explanations, if I had been able to upload, it would have come up here. Unfortunately, it wouldn't upload for whatever reason, that weird data type issue. So here we see the output, which is actually stored in the standard log. So here we have it. So here we've got our global feature importance. So this is the amount that each feature contributes to whether someone survived or not. As we can see, sex of the individual, whether they're male or female, contributes very significantly. Their fare also contributes significantly. This is very much in line with what we know about the Titanic, the women and children first thing, and also the very, very high survival rate of people in first class who paid a lot of money versus third class who did not pay as much. But what I think is interesting is here we have the individuals who were classified their local feature importance, and we can see that the relative importance of each of these features varies quite significantly from person to person. So here, age was the most impactful feature. Here, whether they had siblings or spouses was the most impactful. Class was the most impactful. Sex, again, really impactful there, 0.5 out of 1. That's very interesting. And we can see that there are actually some negative features for some of them that detracted from that particular conclusion. So those are some interesting examples of how you can look at feature importance from a global, whole data set, whole model point of view, and on an individual record point of view. I can definitely see some use cases for these individuals. Like if you were doing an individual risk assessment in a medical or a social care context, you could actually look at what are the contributing risk factors for this individual, where might the most appropriate intervention be? Is it from a social point of view? Is it a medical point of view? Is it a housing point of view? Etc. So I hope you guys enjoyed this and found this informative. I apologize that I couldn't get those nice visualizations, maybe next time, but this is my Machine Learning Monday for today, the 20th of February, and I will see you guys next week. Bye.